Hello, everyone, and welcome to Precalculus. This is section 10.1 on lines. The inclination of a non-horizontal line is the positive, that's going to be key, the positive angle theta less than pi measured counterclockwise from the x-axis to the line. So that sounds like a complicated definition. It's not. I'll draw you a picture. So if I draw a line like that, then this angle right here is called the inclination. If I draw it like this, then this angle is the inclination. It's a positive angle counterclockwise from the x-axis to the line. If I have a perfectly vertical line, then it's the same and it'll always be pi halves. If I have a horizontal line, then the inclination is 0 because it doesn't have any incline at all. So you've actually already studied inclination. We just didn't give it that name. It's the same thing as slope, except that it's expressed as an angle where slope is expressed as a ratio. And what do we know about the relationship between ratios and angles? Well, think about this. If this is theta, and slope is normally rise over run. Slope is rise over run, which is equal to y over x. And how is that related to theta? That is tangent of theta. So there's your relationship. Tangent of theta is equal to m. So the way you're going to think about this is that theta is the angle where m is the ratio. So when people say a slope of 3, you can picture that. You know that that means it's a rise of 3 and a run of 1. But now you need to also be able to picture it if I tell you what theta is. And the relationship is just tangent of theta is equal to m. So nothing new. Let's do some examples. Find the inclination theta in both degrees and radians of a line with slope 2. Now you might be thinking, where do I draw it? You can draw it anywhere. Any line with slope 2 is going to have the exact same inclination. So that's what the inclination would look like. Even if I drew it over here, as long as it has a slope of 2, it's going to have the exact same, do you see it? Inclination. So how do we find that inclination? We can just make any little triangle. So any triangle is going to tell you its inclination. So that triangle is 2 to 1. Tangent of theta is 2 over 1. Now, if you put your calculator in degrees, then this will automatically produce the degree answer, which is 63.435. Now, if you want to put it into radians, this is a little trickier because inverse tangent of 2, I guess I'll specifically change this to 2, is not an angle that you know on your chart. So your calculator will tell it to you in radian measure, if you put your calculator into radian mode, but it may not be something that you recognize. So a quick explanation, this is 0, this is pi halves, this is pi, and this is 3 pi halves. Let's just think about those as numbers for a minute. Pi is the same as 3.14. So if I divide that in half, I get 1.57. So 1.107 must be somewhere around here, which makes sense because that's what my inclination looks like. So I feel confident that that answer is correct. And it gives you a little introduction into using radians without the pi built in. It is an actual number. Okay, let's do another one. This time we're going to sketch a very specific line. 3 halves x minus 1 plus 2. So I know the point 1, 2 is on my line. And I know that from that point or any point on the line, it has a slope of rise 3, run 2. Rise 3 and run 2. So I want this inclination right there. Well, I know that the slope is 3 over 2. So tangent of theta is equal to m. This is going to be your key formula. Tangent of theta is equal to 3 over 2. How do we find that? This one doesn't ask for both degrees and radians, so honestly, I would stick with degrees because it's something that you understand better. Type that into your calculator, inverse tangent of 3/2. When your calculator is in degree mode, don't forget to switch it back because we did radians last, and you will get 56.31 degrees. Does that look like it could be 56? Sure. If I draw a little 90-degree angle there, it looks bigger than 45. If you were to do it in radians, I will just tell you in case you want to practice it, 9.83 radians. All right, let's try another one. Sketch the line. So this one's a little bit more work. You can either solve for y, which is going to give you negative 2/3 x plus 2, or you can use the intercept method. When x is 0, y is 2, and when y is 0, x is 3. So then you don't have to rearrange it at all. You can just plot those 2 points, which allows you to see the slope like that. Does it work even if I did it the other way? Yep. Y-intercept of 2 and a slope of down 2 over 3. So we write down our formula. M is equal to tangent of theta. We fill in the slope that we know because we're trying to find the inclination, which is theta, is equal to tangent of theta. Whenever you know the ratio but not the angle, you always have to reverse it and ask for inverse tangent of negative 2/3, and that will give you theta. So a little backup refresher here. So for inverse functions, there's rules about what angle they give you. So if you have inverse sine of 1/2, you may remember that sine of 1/2 is pi/6. But technically, isn't sine of pi/6 1/2 or sine of 5 pi/6 equal to 1/2? So why did you tell me 1/2? Because that's what the whole world agreed on. Everybody in the world agreed that this was the one we were going to use. But if it's negative 1/2, then everybody in the world agreed that we would use the quadrant 4 answer and that we wouldn't express it as 11 pi/6, but negative pi/6. So if you don't remember those rules, you're going to have to go back and kind of relearn them. But I'll give you a quick summary, and that is if the inverse function is positive, so I'm just going to write inverse function of a positive, the answer is going to go here every single time. But if you have inverse sine of a negative number, you're going to put the answer here. If you have inverse tangent of a negative number, the answer is going to go there. But if you have inverse cosine of any negative ratio, the answer is going that your calculator is going to give you is going to be quadrant 2. That's just what the whole world agreed on. They couldn't put it in quadrant 4 because cosine of a negative number is not negative in quadrant 4. So when you go to do this one on your calculator, this is a really important little point here. You're going to get theta is negative 33.69. And half of you are going to write that on your quiz, and I'm going to mark it wrong, because this is the angle that they just gave you, negative 33.69. However, by definition, inclination is the positive angle from the x-axis to the line. So in order to actually get the inclination, this is the correct answer for inverse tangent, but to get the inclination, you're going to have to subtract from 180. So 180 minus 33.69 gives you a final answer of 146.31 degrees. And honestly, if you just sketch it, you're going to see that negative 33 is wrong. If you mark what the inclination is before you start, I don't think that you'll forget. It doesn't specify degrees or radians, so I would leave it in degrees because I think that that's probably a little bit easier for you. All right, so this time we want to find the slope with an inclination of 56.3. So same formula, doesn't change, but now we get to use it the other way. The slope is going to be tangent. So if they give you the slope, you have to do all this work to find theta. If they give you theta, you can just plug it in. Hopefully your calculator is still in degrees and you get slope is equal to 1.5. You might want to convert that to a fraction to make it easier for you to graph. It doesn't matter where you start. So just to show you that, I'm going to make my x-intercept over here, and then I'm going to go up 3 and over 2, because that's what the slope is. And then I look at it from the x-axis to the line. Does that inclination look like it's 56.3 degrees? Sure, that looks like it could be 56.3 degrees. So I feel good about it. So find the slope, 3/2. You could have sketched that line any place as long as it has that inclination. Find the slope of a line with inclination theta is equal to 2 pi thirds. So you could, well, let's just write the formula first. M is equal to tangent of theta. Remember, when they give you theta, you're good. You're set to go. So you could put your calculator back into radian mode and just type this in if you want to. Or you could make me so happy by remembering, oh, tangent of 2 pi thirds, that's in quadrant 2. So tangent is going to be negative. And my reference angle is pi thirds, and tangent of pi thirds is the square root of 3. There you go. That's what it is. So it does say to sketch the line. How are you going to sketch that? So it's easier as a fraction, and you're going to want to just approximate that as a decimal. So square root of 3 is approximately 1.7 over 1. Or you could change it to some kind of a more fractional number, 17 over 10, but we just don't have that much room. So as small as it is, I'm going to go from any point, this time I'll start at 1, down 1.7, and then over 1. So I'm only going to draw 2 lines because I can't keep drawing 1.7 accurately. But the question is, does that look like 2 pi thirds? Let me draw it on the origin, down 1.7, right? So think about where 2 pi thirds was. Does that look like where it was on the unit circle? Somewhere over there? Yeah. So you should be feeling very confident about that answer. The slope is negative square root of 3. Next one. Find the inclination of a line passing through the points 9, 6, and -4, -3. So it looks something like that. So already I'm predicting my answer. I'd better get an answer no greater than 45 degrees. So my slope is y2 minus y1 over x2 minus x1, -9 over -13, which is positive 9/13. Now I can use my formula. Just write that formula every time. So 9 over 13 is equal to tangent of theta, inverse tangent. So remember the last two, we knew the angle when we were trying to find the slope, a little bit easier. When you have the ratio or the slope and you're trying to find the theta, you always have to use the inverse tangent function. And you get 34.695 degrees. So do you remember what I said in the beginning? That if it came out to be more than 45, I would be worried that I had done it wrong. But this definitely looks like this could be about 35 degrees. I definitely feel good about that answer. Next one. New formula. If two non-perpendicular lines have slopes m1 and m2, The angle between the two lines is given by this formula. So they've made your life really difficult just to practice some math from the beginning of the year, get you ready for your final. So I'm going to move the y to the other side. I know 1 point is 0, -4, and it has a slope of 2. So I graph that. And then my other line is going to be 3x plus 4y is equal to 12. You could get y all by itself on one side, or you could say if x is 0, y is 3, and if y is 0, x is 4, and just graph it that way. 0, 3, 4, 0, and this looks like that. Wow, they practically look perpendicular, right? Pretty close. So if I'm going to find the angle between the two lines, this formula is always going to find the acute angle. So it's going to find this one right here. So tangent of theta is going to be equal to m1. So this slope is right here. We'll call that m1. And this slope I never found because I chose to graph by a different method. So you can either take these 2 points and find slope, or you can say, oh, I'm just going to rearrange it because that's what I would have done. Divide by 4, divide by 4. So this slope is -3/4. We'll call that m2. It won't matter which one's m1 and which one's m2. That's the purpose of the absolute value, so that you can do them in either order and it's okay. So m2, -3/4 minus m1, which is 2, all over 1 plus m1 -3/4 times m2, which is 2. And then, of course, what's the hardest part of this problem? It's putting this into your calculator. So, of course, I'm going to do it by hand just because I like to. So this is 8/4, which gives me -11/4 on top. And then this is going to be, this reduces to -3/2. If I change this to 2/2, this is just -1/2. I can flip and multiply, and that gives me, it becomes positive, although it didn't matter because the absolute value sign. But this becomes 11/2, which is 5.5. So if you did it on your calculator, you got 5.5. Now, don't forget the next step. A lot of people box this answer. Don't forget, all you did was figure out what tangent of theta was equal to. You still have to do inverse tangent of 5.5 on your calculator to get the answer. So assuming that your calculator is in degree mode, it should come out with 79.695 degrees. So that's interesting, right? It's not 90, but remember I said it's a pretty big angle. It's almost 90. So 80 is definitely, I feel good about the answer. So always make sure that you're making the sketch, and you do not have to do all this math. You can type that directly into your calculator. If you still don't know how to do that, make sure that you ask me in class so that I can help you. But there's the angle between the two lines. Another new formula, the distance between a point xy and a line. So this time you are going to want it in this format. Here's the formula. So unlike last time where they did give it to you like that, this time they didn't. Okay, but you must put it in the above format or this formula will not work. So I'm going to move the x to the other side, -2x plus 1y, and then I have to move the c over also, -1. If, by the way, you put everything on the other side, formula still works. That's what the absolute value are for, so that you can do it either way. And then this is my point, which they're calling x1, y1. So let's go ahead and actually just draw that real quick. So the distance is between 1 and then up to like that, and the point 1, 2, 3, 4, 1. So distance always means the shortest possible distance, which means that it would be perpendicular. So we actually did do this problem in Algebra 2, if you had me. I don't know if you remember it, but it was a little tricky because to find the distance between a point and a line, first you had to find the slope of the line, which of course we know is 2, which meant that then you could find the slope of the perpendicular line, which is -1/2. Then you could take the point that you knew and write the equation of the line, and then you could solve the system of equations, take this line, 2x plus 1, and this line, so that you could find this point of intersection. And then once you found the 2 points, then you could use the distance formula. It was a lot of work, and I made you do it. I was mean. But now you have this formula. So this formula looks awful, but if you compare it to the way we did it in Algebra 2, this formula is awesome. So this is going to be my A, this is going to be my B, and this is going to be my C. So A times x1 plus B times y1 plus C all over the square root of A squared. Now it's actually -2 squared, but once you square it, it'll become positive, plus B squared. And that gives me 8 plus 1 minus 1 is just 8. The absolute value is 8. And the square root of 4 plus 1, square root of 5. If you rationalize the denominator by multiplying the top and the bottom by the square root of 5, you get 8 square roots of 5 over 5, which is not really a helpful answer for checking. So if you type that into your calculator, you're going to get approximately 3.578. So my question is, does that look like it's 4 units long? Sure, a little bit short of that, but that's why it's only 3.5. Okay, so 3.5, yeah, I could definitely go for that. I feel like that's good. If you had gotten this to be 11, you might think you made a mistake. So always draw a picture to kind of check your work. Now we're going to draw a triangle with vertices at -3, 0, 0, 4, and 5, 2. This is C, this is B, and this is A. So it looks like this. And I'm going to draw the altitude from B to AC. So an altitude is always perpendicular. So it's hard to draw, kind of tilt your head maybe to do it. So we did problems like this back in chapter 6, where we found the area of the triangle and then the length of the base, and then we used the area is equal to 1/2 base times height. That's a lot of work, especially since we used Heron's formula and when we knew the lengths of the sides of the triangles. I don't feel like finding all those lengths. So again, totally cool formula that we're going to use to find the altitude. That's just the distance between a point and a line. So because it's on the last page, I'm going to write it really quick. Distance is equal to AX plus BY plus C all over the square root of A squared plus B squared. And the thing that you need to do this is the point. So my point is going to be point B, which is 0, 4. It's always nice when there's a 0. And my line is going to be the line AC. So I'm going to have to back up and do that. How do you find the equation of a line? You need 2 things. You need slope and you need a point. So what's the slope of this line? Well, since I drew it, I can just count. Rise of 2 and run of 1, 2, 3, 4, 5, 6, 7, 8. So 8 2 over 8, or 1/4. And x minus, now I could pick the 5, 2, but I'm going to pick the negative 3, 0 because it has a 0 in it. So negative 3, 0. But remember, this format's no good. But luckily, you know how to clear fractions. I'm going to multiply both sides by 4. And then I'm going to put everything onto one side. 0 is equal to x minus 4y plus 3. Last time I moved these two over, I'm showing you that you can move these over. And then identify your a, b, c. A is 1. Give myself a little more room there. A is equal to 1. B is equal to negative 4, and C is equal to 3. So it was still a lot of work. I had to find the equation of the line and put it in the right format. But now I can use this and this to do this problem. So absolute value of A times X plus B times Y plus C all over the square root of A squared plus B squared. And that gives me, this cancels because it's just 0. Negative 16 plus 3 is negative 13, but since it's absolute value, it's positive 13 over the square root of 17, which is 13 square roots of 17 over 17. Do you even remember what we were looking for? It's the height. So we just found this distance right there using my very cool formula. So now, part 2 of this question is find the area of the triangle. Area is 1/2 base times height. So area is going to be 1/2 the base times, and you can just leave it like this if you want to when you're still doing more math. So what is the base? Another formula. So to find the distance between A and C, you're going to use the distance formula. So you're going to be so ready for your final because we're going to keep using all these old things that we've learned. y2 minus y1 squared. So A is the point negative 3, 0, and C is the point 5, 2. So x 2 minus x1 is going to be 8 squared. And then y2 minus y1 is going to be 2 squared. That gives me 64 plus 4 is 68. So this you can break down into parts you can do and parts you can't. What is that going to be? 4 times, oh, of course, 17, because look at that. Look what it's going to do. This is 2 square roots of 17. So that's the base. And look at that. Look how nicely this problem is going to work out. The square root of 17 is going to cancel. The 2's are going to cancel. And I'm just going to get an area of 13. Oh, that worked. So this problem had a ton of steps. And you will probably need to watch this portion of the video more than once because I am not going to do the extra example. When we go back to class, you are more than welcome to do this one in class while I'm sitting there right there with you. But the altitude is going to be 33 over the square root of 29, or if you want to rationalize it, 33 square roots of 29 over 29. And then the area is going to be 33 halves, or 16.5. I want you to draw it. And then I want you to just go through this very long process that we did for number 2 here. The steps are absolutely identical. It'll kind of solidify it in your mind. All right, the distance between the parallel lines. So you're trying to find the distance between lines. So at first you might look at this and say, is it the distance between between lines, then we're going to use this formula. But you should always draw it first, and as soon as we do, you'll see why. So I can't use my little intercept method, so instead I'm going to do negative 4y. Nah, actually I'm going to move the 4y over and the 1 over. 3x minus 1 is equal to 4y divided by 4 divided by 4. So I can see that this slope is 3/4 if I were to separate them, but I'm not going to separate them yet because I really want to get at least one good number that I can plot here. So I think to myself, if I do 7 times 3 is 21, minus 1 is 20, so 7/5, which is a little bit big. How about -1? 3 times -1 is -3, minus 1 is -4. There we go. So now I actually have 2 points if I could do the 7/5, but I know the slope. Up 3, 1, 2, 3, 4. Oh, so apparently, oh yeah, 3, 2 would have been a point. So there's lots of choices for getting that one good point. But there's my red line. And then my blue line is going to be 3x minus 10 is equal to 4y. Again, divide by 4. And while you may eventually want to write it like this, I don't want you to start at 5/2. I want you to plot one good point, and that's easier to do from that format. So I need to think of a number that when I multiply by 3, the first one that comes to mind is 6, because 18 minus 10 would work. But again, if you're thinking that wasn't really very convenient, then let's see if we can find another one. Yeah, 2. 6 minus 10 is -4. Over 4 is -1. So 2, -1, and this also has a slope of up 3 over 4. Down 3, 1, 2, 3, 4, back 4. So how are you going to do this one? Find the distance between parallel lines. So none of our formulas are going to work. Instead, you can just pick any point you want. We'll just pick this one. And that is the point 3, 2. And this line, which is 3x minus 4y minus 10 is equal to 0. Remember, it only works if it's in the right formula. So A is 3, B is -4, and C is -10. And now you can use that formula. So the distance between a point and a line is A, which is 3, times the point, which is 3, plus B times the y point, minus, well, plus C, but it happens to be a negative number, all over the square root of A squared plus B squared. And that gives me 9 minus 8 is 1, minus 10, so is -9, but it's just going to be 9. And then this is the square root of 25, which is 9 over 5. And that's your answer. So this one at first didn't look like it was one of the formulas that we had, but you can use the distance from a point to a line when you're trying to find the distance between parallel lines. All right, that is it for section 10.1. Have a great day.